Welcome, everyone. Let's dive right into how AI agents really differ from um, traditional microservices. At first glance, they might seem like they're built on similar modular concepts. But there's a lot more going on under the hood.
Absolutely, it's fascinating. Both seem to be about modularity, but then they quickly diverge once you dig deeper. What really sets them apart?
Well, one of the major differences is autonomy versus orchestration. Think of microservices like um, highly specialized factory workers on an assembly line. Each one has a strict, narrow task, and they just execute what they're told when the controller or orchestrator gives the signal. But AI
Yeah,
agents, on
that's
the other
clear.
hand, are more like independent experts. Think, uh, a doctor running their own practice. They set their own priorities, decide when to act, and continuously adapt based on context.
So AI agents aren't just waiting around for instructions. They actually take initiative. Like, um, they have some real intelligence behind them.
Exactly. And another point is about being goal-oriented versus task-oriented. Microservices are a bit like vending machines. You put in a specific input, press a button, and you get a predictable output, exactly the same each time. There's no broader purpose behind it other than executing that one function.
Right. In contrast, AI agents act like consultants. They're not just handling one off tasks, but are focused on achieving broader objectives, whether that's boosting customer retention or optimizing a strategy. They can adjust their approach on the fly based on the situation.
Yes, it's like, imagine handing an objective to a consultant and they come up with a tailored plan rather than a fixed mechanical process, repeating the same step over and over.
Yeah, I get that. Interesting. So, what about state management and memory? How do these compare between the two paradigms?
That's a crucial difference. In microservices, state is sort of externalized. They're designed to be stateless, like you could say they're amnesiacs. They process each input as a separate, isolated event. If context's needed, it's retrieved from an external database. Meanwhile, AI agents actually build internal state. They remember past interactions, learn from them, and use that accumulated memory to influence future decisions. It's like having a seasoned colleague who's learned your preferences over time.
hmm So there's a richness there in the ability to truly learn and evolve. That definitely sets them apart from the predictability and modular simplicity of microservices.
Exactly. And then, when we look at communication patterns, microservices stick to rigid protocols, almost like formal business letters, structured, fixed APIs with predetermined formats. There's no room for nuance or adaptation.
Yeah, that structured communication really defines them. And with AI agents, the communication feels more uh, human like, right? They engage in dynamic, contextual exchanges, almost negotiating responsibilities or sharing reasoning in a way that's very collaborative.
Right on point. It's a leap from sending a REST call to having a back and forth dialogue that involves, natural language as well as adaptive strategies. Not to mention, when multiple AI agents interact, they can create emergent behavior, collaborating to develop entirely new approaches that just wouldn't arise from a set of predetermined instructions.
Now, that's an area where I have a slight challenge. Don't you think that sometimes such emergent behavior can get, well, a bit unpredictable and might even lead to inconsistencies? I mean, while emergent strategies are innovative, there's always a risk they may not align perfectly with, say, strict business goals.
That's a fair point. Balancing adaptability with controlled, desirable outcomes is key. But that's where ongoing monitoring And behavioral metrics come into play, especially for AI agents. You need to track goal achievement, monitor for behavioral drift, and ensure that the agents remain aligned with overall objectives. It's a more complex but also a, a more dynamic monitoring challenge compared to
Mm-hmm.
microservices.
Absolutely. Speaking of monitoring, how do error handling and scaling strategies differ between these two worlds?
With microservices, error handling is often managed by predefined patterns, circuit breakers, retry policies, mechanistic responses that are implemented at design time. Scaling is basically just horizontal, adding more instances of a service when needed. In contrast, AI agents have more adaptive resilience mechanisms. They're not just failing gracefully. If one approach fails, they experiment with alternatives, learn from failures, and even update their strategy. And scaling is much more than just computational resources. It involves increasing their intelligence, enhancing their reasoning, and refining knowledge over time.
That's really interesting. So it's not simply about adding servers, but evolving the actual capabilities of the agent.
Precisely. It's like comparing a fleet of identical trucks to a team of innovative problem solvers whose skills continuously improve. The trucks can only go as fast as their mechanical limits, but the team adapts.
Yeah, that imagery makes it very clear. And what about development and testing? It's another crucial area, right?
Definitely. With microservices, you've got unit tests, integration tests, and so on, ensuring that specific functions produce expected outputs consistently. It's all very deterministic. With AI agents, testing is more emergent. You can't just input X and expect Y every single time, because the behavior might vary based on accumulated experiences and context. Instead, you have to test these agents in simulated, often realistic environments. It's a measure not just of correctness, but of adaptive performance over time.
So it's really about evaluating their learning curves and long term behavior rather than just checking a single output.
Exactly right. And let's not forget the architectural patterns that are better suited for AI agents. Agent-oriented architectures, blackboard architectures, and even behavior trees. These allow for perception, reasoning, action, and memory systems to work seamlessly. It's a far cry from the simple request-response cycles seen in microservices.
Very distinct indeed. Now, one area that always intrigued me is the multi agent dimension. How do these interactions change the equation?
Great question. In microservices, you can predict the system behavior by simply adding up the outputs of individual services. But with AI agents, when they interact, you actually get emergent properties. Novel strategies can surface from their collaboration, which are more than just the sum of the parts. It's like having multiple experts brainstorming together and coming up with ideas none of them would have thought of individually.
I can see that. The system becomes essentially more intelligent collectively.
Absolutely. And then we come to infrastructure and deployment considerations. Monitoring for AI agents isn't just about traditional metrics like response times or error rates. It's about tracking goal progression and learning effectiveness over time. And security, too, is more nuanced. With microservices, you secure endpoints and manage access. But with AI agents, you have to ensure they don't deviate from acceptable behavior, preventing any harmful actions from emerging.
That's a complex challenge. It seems like ensuring proper alignment in AI agents is as much about behavioral oversight as it is about technical security protocols.
Exactly. It's a multidimensional approach that requires careful balancing of adaptive responses, goal achievement, and safety measures. And as we look forward, it's likely that we'll see hybrid approaches where traditional microservices handle high volume, predictable operations, while intelligent agents manage adaptive, goal-oriented tasks.
Right? That hybrid model could really play to the strengths of both systems. What are your thoughts on the quantization techniques and the nuances around optimizing these large AI models that the content touched on?
Oh, that's another exciting side of this discussion. There's a table that lays out various quantization methods, like AWQ, GPTQ, GGML, PTQ, QAT, and dynamic quantization. Each method has its own balance of accuracy, complexity, and ease of use. It's very much like choosing the right tool for the job based on how important precision is versus the speed of deployment or ease of implementation.
Yeah, selecting the right quantization strategy is vital for optimal performance. And then there's that whole part on AI provenance and transparency. It sounds like there's a lot of emphasis on tracking the origins and reasoning behind decisions made by AI agents.
Indeed, ensuring transparency is absolutely critical. Imagine a scenario where an AI chatbot gives a piece of advice. It's important to know why it said what it did, where its knowledge comes from, and whether its reasoning can be trusted. This provenance is central to not only trusting these agents, but also to continuously improving them through feedback loops.
Mm-hmm. So it's about creating a robust feedback ecosystem where the agents are accountable and their reasoning is auditable.
Exactly. And as we venture into even more advanced reasoning contexts, like synthetic data and contextual engineering, the architectures have to support continuous adaptation. You see, even in multi-agent setups, where emergent capabilities occur, it's essential to have a protocol that manages how context and data are shared among agents. A sort of model context protocol, if you will.
Yeah, that really underpins how these systems can work together effectively. It seems like the future is here where AI agents will blend into our existing architectures, yet operate fundamentally differently from microservices.
Absolutely. We're looking at a hybrid future where deterministic high-volume microservices handle routine operations, while AI agents operate autonomously to tackle complex adaptive challenges. It's a merging of the predictable with the innovative.
Hmm, quite the revolution in how we design systems. Really makes you appreciate the need for new mental models and architectural patterns that fit this emerging paradigm, doesn't it?
Yes, absolutely. Constraining AI agents to traditional service-based models just doesn't do them justice. They need architectures that embrace their adaptive, learning, and emergent nature. It's almost like requiring an orchestra rather than just a set of isolated
Yeah, that
instruments.
analogy hits home. And all of this has deep implications for how we monitor, test, and secure these systems. It's a whole different ballgame compared to microservices.
Definitely. As designers and engineers, we have to think beyond traditional paradigms. It's about building infrastructure that not only supports adaptive behavior and dynamic scaling, but also ensures the agents remain aligned with the broader goals while adapting intelligently.
I think that captures the essence perfectly. AI agents, with their autonomy and emergent capabilities, open up a whole new world of possibilities, but also require a rethink in our design and monitoring strategies.
Right. And it's an exciting time. There's so much evolving in agent-oriented architectures, learning from contextual cues and optimizing through quantization techniques. It really pushes us to innovate in both software design and our
Absolutely.
theoretical
Very
understanding.
exciting indeed. This conversation really highlights that while AI agents and microservices might share a modular nature, the underlying principles of autonomy, learning, and emergent behavior set them worlds apart.
Exactly. It's not just a technical distinction, but a fundamental shift in how systems can think, interact, and evolve on their own. Thanks for the great chat. It's been quite the deep dive into modern AI architectures.